whenever you see one of these, how do you identify it? A simulation would be when you're given a problem and it asks you to create a random way to assign people to things and record them. I know that seems kind of vague, but it's just taking your assignment and taking it a step further and recording the results. We'll never actually do anything with the results because you would have to do the trial at least 100 times in order to have any information that's beneficial. And we won't make you do that, especially on an AP test. It would probably ask you to conduct 3 to 5 trials. So it's asking, do you know how to randomly assign people to groups? And do you know how to use that random assignment to execute how you would go about doing it? So on the next page, you'll see a checklist. There are certain things that when you're conducting a simulation, you have to include. So I have a checklist for you, but let's go back and read the problem and then see how we would go about doing this. So here's an example. It says some statistics students are designing a game for a school carnival. At the carnival, a player will throw 3 darts at a target with 3 concentric circles. The 3 regions are labeled with the number of points that a player will earn. So there's playing darts. If you get in the center, 10 points. Second circle is 5. Outside circle is 1. And then if you don't hit the dartboard at all, then you get 0 points.
This is if the dart misses a target.
If a dart misses the target, the player can throw again. Okay, that's stupid. Anyway, everybody wins. So you always will at least get a point. So here we have a table that has the percentage of total area. So the 10 points is 6%, 33%, 61%. The students want to determine what the winning score should be so that approximately 40% of the players win the game. A player would win if they received at least the winning score. And so we're going to create a simulation where we're assigning or having a random. So how would we conduct this simulation? Then we're actually going to execute 3 trials. So 3 throwing of the dartboard. So every single trial would be throwing 3 times. Okay? And we're not even going to count the 0 times, like if they get 0 points. Then we're actually going to do this together and see what the winning score would be. So you'll only do it 3 times on a random number table.
Okay, where's the dartboard?
But then we're going to actually use a random number generator and see what the winning score should be. So we'll actually conduct 100 trials together. So flip to the next page. We need to write up what we're going to do first. Then we can actually do it. So here's the first checklist. What's the plan? So where are the numbers coming from? Typically, we will do a random digit table because that's what they've given us. So we'll use a random digit table if that's what they give us. But if you were just doing this as a free response for me, you could say a random number generator. But typically on these questions, they'll give you the random digit table. So we're going to learn how to do a write-up with that today. What numbers are you choosing from? What do they represent? Are there numbers that you need to omit? In this case, we're using 2-digit numbers because we're going to look at the area. So we're going to look at the area, and that's how we're going to decide which part of the dartboard it lands on. Okay, so we'll use random digits, 00 to 99. So here's the digits I'm using. And they are coming from a random digit table. So from a random digit table. And those numbers are going to represent what? So if I get a 5, whenever I'm looking at my random digit table, or like let's say here, I get a 32, what are those numbers going to represent? If I get a 32, what does that tell me? My score. So it's going to tell me the number of points that I earned from throwing the dartboard, or throwing the dart.
Shouldn't the max be 30 then?
No, because I'm looking at the area. So all of this adds to 100%. because you have a 100% chance of scoring. So I'm going to look at the area, then whatever number I get is going to translate to how many points I earn. So they are going to represent the number of points earned from throwing darts. Just going to write on top of this. The next thing I need to say is I've said what they represent, but now I need to assign certain numbers to numbers of points. So if we go back to the chart, percentage of total area, there needs to be 6 numbers that represent getting 10 points. Typically, I start from the bottom and I go to the top. So I would say 0, 0 through 0, 5 would be. Now you could choose like 1, 5, 7, 10, 13, and 17, but I wouldn't do that to yourself because that would just be confusing. So I will normally go in order. So I'll say 0, 0 through 0, 5 represent earning 10 points. And the next 33 need to represent earning 5 points. So I would say 0, 6 through what? Add 33 to that. 39, 40, 39. So 0, 6 through 39 represent earning 5 points, and 40 through 99 earn 1 point. It's 38. Yep, you're right. Because you got to count.
Why is it 99?
Because they're 2-digit numbers. So 100 would make it a 3-digit number. So they came from a random digit table, 00 through 99. I said what they represented. There are no numbers that I need to omit at this moment in time. If these did not add up to 100, then they only added up to 60, then you would say omit numbers 61 through 99 or something like that.
So if you had to do that for the first question, do you just say 00 to 60?
No, you'd say 00 to 99, but omit 61 through 99. Mm-hmm. The second thing is repetition. Can I repeat a number? So could I draw 32 and then a number 32 again?
Yes.
In this case, yes. So numbers can be repeated. A case in which they couldn't be repeated would just be like if you're choosing people. So if I were pulling out 5 people from the class, if somebody's been chosen, they can't be chosen again. The next sentence is to describe what one trial would look like. So in this case, one trial is to choose 3 random numbers and then add up the points. So one trial, I'm going to put this in a different color. One trial is to choose 3 random digits. And then the last sentence is once you've executed one trial, what do you do with those numbers? So one trial, choose 3 random digits. What do I do with those numbers? So I find the corresponding scores and I add up the total. So I will record. This is how I always start the last sentence. I will record the total number of points earned. So kind of the key phrase there is like, what are you going to write down? I'm going to write down the 3 scores. Last step is to actually conduct the trial. So let's do 3 trials. I'm just going to put trial 1, 2, and 3. So I'm looking at the random digit table. I have 32, 13, and 37. 32 gets 5 points. 13 gets 5 points. 37 gets 5 points. So, looking at the random digit table, like if I am assigned the number 32, that fits in the 5-point category. Because it includes any numbers 0, 6 to 38. So this person scored 15 points. So try the next 2. Try trial 2 and trial 3. Times. So I got 15, 11, and 11. I can do nothing with this information, so I cannot actually answer the question. So it's kind of depressing because you'll see a question and you can't actually answer it. You can just create a simulation. But we are actually, since we have enough of us, we are going to answer this question. So we want 40% of the players to win. So what I need you to do in your calculator, how many people do we have? 10? We have 10 people, so I need each of you to do 10 trials on your own. Okay, I know that's a lot, but I need everyone to do 10 trials. So that's going to be how many random digits? 30, right? Because you'll do 3 digits per trial. Huh? No, you're not using the table. You're using your calculator. So I need you just maybe on a separate sheet of paper to write down the total amount of points for your 10 trials. We've done it before with the jelly blobbers. You go.
This is amazing.
You guys have
No, everyone does not.
We have no idea.
You have no idea. Oh, God.
Oh!
Nick,
I hate-
get rid of our dog.
Yes.
You bet I did.
What?
God.
No, you did
Bye,
not.
Chief.
There we go.
I hate this so greatly.
Whitley.
Whitley. How do I change color?
Oh, wait.
Click the pen.
And
then pick your color.
I'll be there.
One person.
Bridesmaids. Oh.
I wasn't asked to be a bridesmaid?
Oh no, your name's on here, Rebecca. Don't worry.
Okay.
If we do this, I'm gonna get you a gift.
I'm never.
I don't want
bringing
to
you-
count all of
I'm
those.
never bringing you Starbucks again.
You've never brought me
Guys,
Starbucks
the date on there,
anyway.
the address,
It's
and
true.
the time.
Because you didn't send me your
We
order.
will be there.
So, it's kind of your fault.
Yeah.
Because you know the percent chance.
Our data is.
What's 6 over 99?
0.00125.
0.00125. Okay.
Percent that you get a.
So it's a
You
point.
haven't done it yet. Color of you not.
Whoa, when did you guys go to the state fair?
Yeah, when did you guys go to the state?
Like a year ago.
A little,
Last year.
I want to change colors.
How
do you change colors? We could have been K again. How do you change colors?
Posting these on social media, you could get hacked.
Okay.
Green one for him is a B.
Bob.
Wait, what?
Hmm.
That's gonna be like
I'm doing. What color should I do, AR?
Cyan.
Do white. Do white? Yes. No, I'll do.
Right. We need to
I'm not. I'll do orange.
We were done and then we deleted it.
11, 12,
I accidentally did the same color as Logan.
7. Oh my. 7, 11,
Miss Morris hacked your LinkedIn account
7.
as a warning.
As a warning to your LinkedIn.
Wait, which number am I on? 11 again.
89 days to go.
There's a countdown?
Why is a domain?
There's a countdown. Dude, we definitely need to show up on that day.
No, I'm not that much of an asshole.
No, we don't have to be bad.
Alright, I'm done.
It's at 6. I'd have to go directly from work.
Just take this up there for me, dog.
I got you. I got you.
I appreciate it, man.
No problem.
Have people like
Yes.
we've gotten 3 matches in total.
3
matches.
None of them have responded. One of them responded.
Oh, yeah. Tinder?
We only do above 40-year-olds.
Okay, we're gonna go sit back down.
Can I show you the text?
Okay.
Wait, Janine, just read this really quickly.
Enter.
All right, go sit down. Go sit down. Okay, what we're gonna do now is we want 40% to win. So I'm gonna count from the top. There's 100 data points. So we'll count 40 down, and then that'll be the score. 1, 2, 3, 4, 5, 6, 7, 8. Okay, right here. So it's 11. So if you get 11 points, you win. Anything less than that, like 41% will win.
It's too high.
11 points.
Whoa, 11 points.
So here we have an example. It says Snap Crack cereal advertises that you get a ballpoint pen with every box of cereal you buy. There are 6 different colored pens in all. How many boxes of cereal would you expect to buy on average to get the complete set of pens if the chances of getting each pen are the same? So here we have
Boy, trying to learn.
we have 6 colored pens. Our goal when we're doing one of these problems is to use 1-digit numbers if possible, because 2-digit makes it a little bit more complicated. So that's our goal. In this case, we have 6 different colored pens. We could assign to 6 different digits, which would, in case, we would have to ignore 4 of them. Because if there's 10 digits total, 6 get assigned to a different color, 4 we would have to ignore. So
Why can't you just do zeros, like only from 0 to 6?
you have to do the whole set of 1-digit numbers. So you have to do 0 to 9, and then you ignore. Guys, stop talking. Thank you. So I will use digits 0 through 9 in a random digit table. And what are they going to represent?
Represent one of the colors.
So represent the colored pens in a cereal box.
How did you come up with that number? Yeah.
Nope. Cereal box.
How did you come up with 0 through 9?
Those are all the 1-digit numbers.
Oh, so we're just gonna do it like that now.
So you'll either have like 0 through 9 or 00 through 99 or 000 through 999, like 1, 2, or 3-digit. The less digits, the better. So if you can fit them into 1 digits, then do that.
Oh, good one, I got you.
Ignore. Well, I'm going to write what each one, so digits 0 through 5 will each represent a different color. Ignore 6 through 9. So that's assigning each individual unique number to a different color and then saying which ones that we ignore. So we have used or done step 1, where we've assigned numbers to what they represent and then said which ones we omitted. Step 2 says, can there be repeats? Yes, so numbers can be repeated. Just means you get the same color. Next thing is what one trial looks like. So in the last case, one trial looked like picking 3 numbers. So sometimes you will choose a set number and then you'll stop. In this case, it's not going to be a certain number that I choose. It's going to be that I'm going to keep going until something happens. So what's the goal for this person? They want to do what?
Find all 5 pens.
They want to get all 6 colors, right? And so that may take a bunch of cereal boxes for that to happen. Kind of like the trial that you just did. If you wanted to get 30 points, you had to keep hitting the calculator until it finally happened for one of you. So in this case, we call that a stopping rule. There's 2 different types of stopping rules. One, like the last example, you choose 3 numbers and you stop. In this case, you're going to keep choosing numbers until a certain outcome occurs. So one trial, I'm going to use green. One trial is to choose random digits until, so here's my stopping rule, until all colors have been selected. This is different than the last example because the last example I just chose 3. Now I could choose 20. I mean, it could be as many until I get all 6 colors. So that means I need digits 0 through 5. The last thing on the checklist is what am I going to record? So one trial happens. What do I record? The number of boxes of cereal that I had to buy. I will record the number of boxes of cereal purchased. Now, if we did this 100 times, I would want to find the average of how many cereal boxes it took. So on average, it takes about 12 cereal boxes before you get all of them. But we're only going to do it 3 times, okay? So I'm going to start with the first one. I've got 6. Wait, we're not even using 6. I'm going to cross through it. 6, 6, 9. I've got a 2. Got a 5. So you can kind of see what I'm doing. I'm circling, even if they're repeats, I'm circling them and I'm just crossing through the ones that I ignore.
18. Oh.
And I stop here at this 4. Is that right? 0. I have 0, 1, 2, 3, 4, 5, 6. Okay, but the ones that I ignored, I don't count. So I only am going to count the circled ones. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for trial 1, I had 10 cereal boxes. So try trial 2 and 3. So when you do conduct the 3 trials, 10. All right, let's look at the next one. Let's look at the next one, and I kind of want you to try doing this one on your own. So let's look at the last one.
Trial 3 was also 10.
3 women.
All right, shh. A jury consists of 3 women and 9 men.
Sexist.
The lawyer for the defense, believes there is gender bias in favor of men in selecting the jury. Interesting. What is the probability of choosing 9 or more men out of 12 people by chance? Okay, we're going to assume with this that the probability of men and women is equal. So anytime you're talking about like choosing between genders, the probability is 50-50, okay? Because we just assume population-wise 50-50.
But that's not correct.
Then that's what you assume in AP statistics.
But wait, there's more than 2 genders.
Is this gender
No.
identity or is it genetic gender?
Is
this sex assigned at birth?
No.
I'm gonna make that my
How'd you get your numbers? 1 on the 7, 2 out of 5, and 3 out of 8.
They're avoiding.
Why did you
These
not-
I used,
why
I
did you highlight
counted.
the second 0 on number 1.
Oh, wait, never mind. That's just smile.
Ooh, I didn't. You're right. That should be 8. Thank you.
Inquire.
No problem at all.
Oh?
Why'd you get 8 on the third one?
The third one is 8.
I have 7, 6, 6.
If you did even odds, you get 7, 6, 6, I think.
I miscounted
I did the
because I
opposite.
had to
Like
erase.
5 to 9 is male.
Odd even? How dare you? Did you get 5, 6?